Hello everyone. Today our session for cybersecurity and CH, which is Certificate Ethical Hacking Bootcamp. Last time we reached to video number 5, and we already explained about the introduction for ethical hacking for cybersecurity. And today we need to learn and talk about networking. Okay. Before to jump to our lab, in first lab will be food printing and reconnaissance, and before that we need to install and prepare our lab, which is Linux. Okay, it has a Linux and server, which is Kali, and also we have a Windows server 2012. Okay. Also we have Windows, maybe Windows 10, something like this. Okay, this is our lab for next session. We need to start with food printing. So let's now jump to networking, and we need to finalize networking. It's a very important session before jumping to cybersecurity lab. Okay, so today we'll talk about computer networking fundamentals, but by the way, I will try to talk from end to end. This will be a very good session for any person in academic or even in the workspace, I mean at the offices. He need to work as network engineers, or maybe technical engineers, or even pre-sales engineers. He need to make a design. I will try to cover most of the information to be very useful information for all of you. And let's go now. So the first thing we need to talk about about OSI. What is OSI? OSI is Open System Interconnect Standards. It shows you how we communicate between network devices. It consists of 7 layers. Okay, each layer it has own function, and each layer is connected with upper layer and below layer, or above layer and below layer. And we'll discuss now about those things. So the 7 layers started from up, which is application like HTTP, or HTTPS also, FTP, File Transfer Protocol, SMTP, Simple Mail Transport Protocol, SMTP. Okay. Then we have many protocols. Let's talk about HTTPS or HTTP, which is Hypertext Transport Protocol, where it can the server communicate with the web application or web browser in the client to communicate the data and communicate the web pages and so forth. For the File Transfer Protocol, to share the files between the entities, I mean the devices in the networks. So this OSI, it show you how you start to communicate with one device to another device. These are standards. So it consists of application layer, presentation layer, and session layer. The first 3 layers is called datagrams layers, okay, or data layers. Okay, the 4 lower layers called network layers. We'll talk about one by one. So for example, the application layer is the connection between the user as a human to a computer. Okay, where we have application, and the human here understands the application, because each application is for specific function. Let's say I have application for IP telephony, I have application for email, I have application for data transferring, browsing as HTTPS. Okay, many applications. Each application has own protocols. And the human who need to connect to application, he can have GUI, which is graphical user interface, and easy to write and make a command for these applications, interconnect, okay, or interact. So now the application will be readable. The human can understand application, but the application should be translated to a computer language. First translation will be using presentation layer. Okay, it will present the data from the application or human to a machine language. Okay, be understandable, or the computer understands this language. Then we have a session language, layer. The session layer, it can manage and control all the sessions in the computer, for example, and open sessions can manage and control. Then we have transport layer, which is TCP IP, okay, or UDP. We'll talk about it in the next slide. Okay, before to talk, I'm taking just as brief and overview. Okay, then transport layer is responsible for the port numbers. For each application, it has port number. And TCP IP, it is orientation or oriented connection, is responsible for connection end-to-end between the two computers or two devices in the networks. UDP, it's not connection oriented. It sends data and it will not send any acknowledgement to the sender device, even if not receive the packet, will not send. But TCP IP, which is connection orientation, it can tell the previous device, I did not receive the packet, please resend again, for example. Okay, it's verified the connection is validated and confirmed. There's a connection, total packet are sent and received. We have a network where we have the IP addresses. When it has your router devices to route the information from the one LAN, I mean local area network, which is, let's say, your home or maybe for your office. You need to connect to another place, other LAN. Maybe you need to connect to Google or connect to Facebook. Facebook also a LAN, but it's a very large LAN, for example. So it can use IP address to communicate with other devices through the internet. Now we have data link layer is responsible for connection between devices inside the network itself. It not use IP address, it use MAC address. MAC address. A physical layer, it is the physical layer from its name, like wireless, like cabling, UTP cabling, or computer cabling between the devices inside your network or your home. It's called physical layer, where this can send the packets or the frames into bits inside the media communication layer or physical communication layer, like fiber optic, UTP, wireless, and so forth. So we have, let's remove this one. We have cabling, UTP cabling. When we started with Cat5, Cat5e, it support 100 megahertz the wavelengths bandwidth we communicate, and it support 1 gigabit per second, 1 gigabit per second. Also can support sometimes for E more than this, but for limited distance. So to Cat6 and Cat6a advanced or enhanced, it uses also 1 giga and uses 10 gigabit per second. It uses 250, 500 megahertz the bandwidth, I mean the frequency for the communications in the cabling or whatever. It uses UTP, which is unshielded twisted pair. I'm talking about unshielded twisted, which is a cover cable with a jacket and cover. So let me give a small hint about how the networks are working. First, let's open new session, new here. Let's say new slide, to be easy for you to understand about networking inside the LAN. So we have computer. This computer connected with the socket on the wall. It's called outlet. This cable, 3 meter maximum should be, or 5 meter, whatever. We'll talk about some distance between computer to computer. Now this computer connected I'm telling you as a low layer connection overview to understand everything. Then what? Sorry. Okay. Then there's a cabling going to the maybe false ceiling. If there's a false ceiling, let's say we have a false ceiling here. Let's see here. False ceiling is run inside the false ceiling to where? To communication room. Here we have a room. It's called communication room. Com cabinet. Com cap. It's called com cap. Mean com cabinet. Okay. Okay. Where we have patch panel here for cabling. The cable will come and will be terminated. Before that, let me draw the patch panel for you. Okay, like this in the front. Is RG45 small outlet. It could be have 24 or 48 port patch panel for cabling. Then what happened? This cable terminated at the back of this port, and the front of this port, this one cable called drop cable or batch cable. Also this is called drop cable. And this here will be a switch, active component. It is a switch. Switch is active component, has 24 or 48 ports. Okay. Then I have another computer. For example, here's one computer. Okay. I have another computer, and so far maybe I have hundreds, thousands of computers based on the size of the company. Then the same, the cable will come, drop cable to the outlet, outlet coming again to the false ceiling, go to the computer room, because here computer room will be inside computer room. There's communication cabinet, which is that one, connect to other port at the back. From inside, from the front, this drop cable will come to the next port. Okay, is 1 meter cable. 1 meter cable. Here, usually 3 meter cables or 5 meter cables based on the location of the computer far from the output or on the wall. Okay, is output in the wall. It's called node also. Node 1, node 2, and so far. Like this, the connection of cabling. Then maybe I have other floor. I have main communication unit, and I have maybe this floor is very large. It has other communication unit here. This is main, where I need to connect fiber optic cable from. I have one patch panel for fiber optic cable. It looks like UTP, but it's for fiber. It has many ports. Okay, later we'll discuss about the port. So what happened? If this is a main cabinet, I put here core switch or distribution switch, big switch, where all switches, core or distribution switch, all the switches inside the cabinets or locations switch, for example, should be connected to the core switch by fiber optic if the distance more than 100 meters. More than this, you should use what? Fiber optic. Less than 100 meters, maybe I can use UTP. But now UTP is support maybe up to 10 gig, for example, 10 gig for 100 meters. Maybe the core switch now, new core switch support 40 gig or 100 gig fiber optic. Maybe UTP can support 40 gig, okay, but it has limited distance to 30 meters for UTP. UTP, I mean STP, shielded twisted pair, which is better than UTP because it has the shielded metal around to eliminate the electromagnetic interference. So now we have fiber optic connect where from each switch, of course, to the patch panel with the fiber optic, then in the riser shaft between the floors to the other patch panel of fiber optic, from patch panel to drop cable to the port. Okay, this is fiber drop cable, batch cable, fiber batch cable, okay? And then the other switch, the same, coming to fiber to this one and to that one. That means the core aggregate all the switches inside the LAN, okay? That's the line. The core switch aggregate all the switches to make communication between all the switches, all the networks, okay? Because I have thousands of outlet or computers or whatever devices, IP printer, laptops, and so forth. Also, don't forget, also I can use wireless access points inside the area. Access points. To connect, I need to connect through cable. Okay, again, UTP cable. Go again to the batch panel, connect to the board of the switch. And another one, batch panel, again to the board of the switch. This is how to communicate for wireless. Also, we have here another access point in different floors. All are connected to patch panel, then of UTP patch panel, of course, then to the switch, normal switch, not core switch. And this, the normal switch connected to the core switch as well. Maybe no need to patch panel, directly in the side, the cabinet, direct cable, drop cable. Okay, could be 1 gig, 10 gig, 40 gig, whatever. Okay, maybe through fiber optic batch cords. Fiber optic batch cords, or maybe UTP based on the design. And at any rate, what happened here? This access point communicate with users. Could have the user have let's say laptop or having smartphone and so far. Okay, he communicate with the access point. Access point 1, 2, and so far. So what happened here? We have to have one device connect to the core switch or other switch inside the main cabinet, or even any switch inside the other cabinets. One device called what? I put it here. Wireless controller. Wireless controller, it can manage all access points and manage the communication between them, interconnect between access points. Maybe this user is going to another floor, he will communicate with the another access point. And this will be roaming between access points. This is a roaming. That means the user, when he reaches to one access point coverage area, he can connect to this access point. For example, when he reaches to this area, then when he go down, connect to this device access point. When he go to other floor, connect to other access point. It's called roaming. Okay. I will not talk about layer 2 or layer 3 roaming, because this is special training for wireless, okay, and how to make the bands and non-overlapping between the access points channels. I will talk later on in the access point as in wireless training, okay. Just briefly, I explained to you about LAN networks as a lower design, called low level design, okay. Just to show you how it can interconnect between devices and switches and so far. Only remaining thing I need to ask to put here, a router. Could be a device inside the access point, the cabinet. This router connected to internet through ISP, okay? Through ISP for internet. Of course, after router we have firewall. Firewall to secure the connection inside the networks. This is also special training for firewall in security, specialized security training for firewall. We'll discuss about it later on. Just briefly, this is our LAN connectivity. That's all. So let's continue in our training for let's say OSI. Okay, there's two standards for communications. One standard called OSI, Open System Interconnect, is international standard. It describes 7 layers and how it communicates between devices in the networks. The another standard called TCP/IP, it has only 4 layers. But as you see, the upper 3 layers of data is consolidated in one layer called application. And the transport is same transport, network same, and here named internet, because network use IP for internet routing. Okay, same, but here the name is internet, and both data link layer and physical layer as a network access. Okay, the difference between them, but the function will be same. I will describe for you OSI. Now back again to no need to explain here. I will open something else. It's called Cisco application. Okay, this one. Okay, I make very easy and simple networks here. I have let's say a computer. It needs to communicate with another computer in another networks. Maybe this is called one through internet. This is no need to know this one. Again, escape. Okay, this is one. I have many routers, by the way, but I just make it a simple router. Okay, I make one PC, double click. I make configuration for this PC. What I make it, close this one. I config. I make it 192.168.1.11, and the default gateway, which is a router. Sorry, I make configuration. This should be 2, and the default gateway in the router. And the one, the other one. Let's go this one first. Okay, the other one will be one here, and default gateway 1. Okay. Right. Remember. Sorry. Here 192.168.1.0. The network, I mean. Okay. Here dot what? Dot 11. And here the router dot 1. Okay. Same network. Instead of 0.1 router, here dot 11. Again, just to what? Check again the configuration of the PC. Escape. Go to command prompt ipconfig. I have IP address 1.11, and default gateway should be the router. This gateway. This interface called 00. Put it in Ethernet 00. Okay. Now I need to configure the router. Okay. The switch, no need to make configuration. I connect this PC, which is 192.168.2.0. The router, I make it what? 0.2. The PC, I make it 0.11. Of course, that mean what mean 192.160.2.11. The router .2.2. Okay. So let's configure the router. So I need to know the fast Ethernet 1 is better to know this one. Fast Ethernet 0/1. The other fast Ethernet 0/0. Just to know for the interfaces. So let's now open the configuration of the router. I need to show you how I can configure Cisco router. First, it told me I will run initial. I said no. Now let's do the configuration together. Minimize. Okay, let's come here. Now enter. Remove this one here. Okay. Enter. Now first I need to enable. After that I need to go configuration mode, config T mode, where I can do configuration. First I need to configure fast Ethernet 01 or 00, start with 00. Okay, make sequence. Interface fast 0/0, then IP address will be 192.168.1.1 in the router itself, right? 255.255.255.0, the IP address of the router in the interface connected to this area. Enter. Then I need to make no shutdown for the interface. Okay, started to make no shutdown, it will work. Then I need to go to the other interface, which is 0.1, and I give IP address what? 2.2, right? 2.2 of the router. Then I make no shutdown for the interface. Now it works. Then I need to make routing between. I can make static routing or dynamic routing. Let's do dynamic routing. RIP. How to do it? Go to the exit previous mode of the configuration, main route. Now I need to make IP route first. IP routing. Okay, IP. If you don't know, you make question mark. You know what is the word you need to write. IP routing. IP routing. Enter. Then IP RIP, I think. No. Or RIP. Router RIP. Router. If you don't know, I'll show you something. Go question mark. What command I can start? Let's say router. Hey, router. Okay. Make. Okay. Enter. Make router. I don't know. For example, question mark. What router? What router? I have RIP, routing protocol for internal protocol. I can use OSPF as well. So we'll do it very fast and easy. RIP. Okay, small network because RIP. Enter. Sorry, RIP. Enter. So I need to only mention the network. Network, which is 192.168.1.0. Only network. Mask, okay? Subnet, sorry, network subnet. Other network subnet will be 2. Now I should have connection. First, what I'll do, I will make exit. Go again, exit to the normal mode. I make WR, which is or W write memory, just to make safe. In case I make, let's say, the device of router off. If we get off and on without saving, I will lose all configuration I did. So I make it WR or write memory, okay, to save our configuration. So I can come to this PC, double click, and go to command prompt. Say what my PC CLS, so clear. They not support this CLS or clear here. Okay, anyway. So let's go IP config to see my IP address. I have 2.11. So I need to ping what next device. This is computer, I mean, which is what? Ping 192.168.1.11, right? Should be pingable if all configuration correct. Okay. Okay, I stop this one first and let me make ping to the next 1.1. Let me stop this one first. Real time. Go to real time. Sorry. There's something wrong here. Still not working. I need to figure out what. 0 1. Let's come to computer and close this one and go to the IP configuration. You see what's the problem? Default gateway is wrong. Should be the next hop is yeah, it's correct. 2.2. What's up? If I make it, for example, 1.1, what happened here? It works. Look like it works. Ping is bingable and make 11 next. Okay, there's misconfiguration with IP addresses. Okay, I will show you. Now it's okay. It was before misconfiguration with the default gateway. I should put the default gateway to reach what the other networks, which is 1. I should use this one, default gateway, or this one, whatever. Supposed to use one. Okay. Now, if I go there, another one, close this one, and go, I make it 2.2, and close it. Okay. Double click again. I need to connect to what? First IP config. Should be one command. Config is 1.1. Okay. Ping 192.168.2.11, the other PC, okay, is bingable. So now I configure the networks. Usually my default gateway should be this one, okay, of this networks. Other one, my default gateway should be this one, but I don't know how it works. I take the other default gateway. Maybe I need to reach because I have only one router. That's why. If I have 2 routers, each router I put its own default gateway. It works usually the same subnet mask default gateway, same range of subnets. But I have one router. That's why I put other another port. So now I need to show you how the communication from one PC to other PC. Say I go to here, simulate. Let's go now. Start simulation. This is kind of what show me spanning tree protocol, how it's broadcasted from switches, routers, and reach to each place to verify there's no different link and to make loop inside the networks. Spanning tree protocol works to learn to teach the switches and routers about there's no any other link connected to make a loop, okay, to verify. So let me make ping, for example, here, double click, make ping to other device. Now you see the ping started with PC going to the switch, from switch to router. Router, he knows that the destination was going, and go. If you open the bucket itself, double click, I think, okay, you see is using only layer 2 addresses, because what, inside the switch, because inside the switch no routing, because local, use only MAC address. Okay, if you go inside here, you found there's in the MAC address we have destination MAC address and source MAC address, as we discussed, and we have the data going. For the IP, we should have the IP, source IP address, and destination IP address, and the data. We'll discuss this in the next slide, okay? So now I show you how the communication going from one PC to another PC, to internet to another PC, using what? 7 layers, which is open system interconnect. And I show you the configuration inside the routers of Cisco and some network configuration in the PCs. I may have to put the IP address, the default gateway, and so forth. So let's stop this one and go continue our presentations. Okay, even the router stored. So next slide. Oh, before next slide, let's here do the explanation. Okay, for you how it works. It works like this, from up to down, and here from down to up, the communication flow. Why? Because we are using some protocols, let's say HTTP, TTPS, for example, hypertext secure, okay, transport secure, which is encrypted link to encrypt the data. First, the user, he communicate with the applications, okay, as data, and coming to presentation to translate this human readable information to machine informations, and session will control how many sessions are open, manage the session, tier the session, close the session, and yeah, something like this, and control the session and manage. Okay, then we have a transport layer, is communication end to end, responsible for communication end to end. This communication part of 7 layers. Okay, verify the communication is guaranteed from end to end using TCP/IP. Using what? TCP/IP protocol, or even UDP. I will discuss difference between them. Okay, UDP. Then what happened? What happened here? The data, this information, the data called datagram, the name, will encapsulate it in the transport layer. Will encapsulate this information. Let's say this is datagram. Okay, the data will encapsulate this data and put the port number, source, as I showed you before in the Cisco, source and destination port number. Then this information coming here, the next layer as information, we encapsulate it by the network layer, and we'll put what? Source and destination of the IP addresses. For example, my source IP address is my device, this device. Okay, communicate to here, and the destination is another server or device, whatever, server or device is the destination IP address. Okay, here. Now this information will be coming as data and encapsulated again with the data link layer, and they put the source and destination what? It works with not IP, it works with MAC address, device address of the, because any device in the network has MAC address, is a device address. Okay, it's layer 2. The network layer is layer 3. It's routable to different layers and different areas through router, using router here. Okay, routing for the third layer, okay, to communicate with other networks. After that, this information is called here, by the way, segment. In layer 2, segment, okay. In layer 3 called packet. Here in physical called what? Not called, it will be divided information as bits and sent through wireless, fiber optic, UTP to other devices as bits, as digital electrical bits. Okay, it works like this. So let's talk about more details for this one. Let's go to the next one. Okay, as I mentioned, this called data, the 4 upper layers. Okay, this 4 upper layers, 3 upper layers called data. The data will be encapsulated in the transport layer, and he put header In header it has source port and destination port. Okay, then will be interact with the lower layer, which is layer 3, and this information all together will be as this one, and will encapsulate with network header. It has IP, source IP address and destination IP address. Then we'll go to layer 2. All this information will be as here, as networks, and has a frame header, and put the source of MAC address and destination MAC address. The destination MAC address here, by the way, is the router. If we communicate with another device in the internet, the destination MAC address is the router, local router. Because the router here, local router connect to internet, will have another MAC address and another IP public address to communicate with other router in the internet. Okay, data we'll discuss about it. So first is called data, the first layer, 3 layers. Then segment in the what? In the layer 4, TCP IP, here TCP or UDP. Okay, layer 4 it's called segment. In the layer 3 called bucket. In the layer 2 called frames. Frames, not segment. Last time it's frames. And bits in the layer 1, which is the physical layer. Okay. After that, let's make more information about this. Let's talk about the layers. Okay. First of all, the application layer, it will serve the interface between end user application and the underlying network devices, as I mentioned before. Then using some protocol for application like HTTP, SMTP, FTP. I already mentioned that. Then we have, let's say, the presentation layer. It can translate the information from where? From the layer 7. Come back here is better to go more understanding. Okay, here. Okay, layer 7, layer 6 make translation from the readable user information to machine language. Okay, layer session layer will be control, manage, tier, establish the sessions between the open sessions. We have maybe tens or hundreds of sessions are open for different application, because the user itself can open many applications in the computer, right? Something like this. Okay, so for transport layer, it's very important, using TCP and UDP. TCP, it's called Transmission Control Protocol, is a connection orientation, where it ensures the reliable data transfer without any error. Without any error, because it has error checking, will check any error and will inform the, for example, if the recipient not receive some bucket, because the bucket, when the coming here, the information to go to other device, it has a bucket sequence. Okay, sequence number. Okay, this device will tell other device through this OSI, I did not receive some buckets. Bucket sequence number 5, for example. Please resend again using TCP, because connection oriented. Okay, UDP no. UDP even receive or not receive will not ask. More faster than TCP. Okay. Okay. Then what we have here, we have network layers. Network layers is responsible for data routing and forwarding the addresses between different devices. Okay, using internet, using IP address, as I mentioned. Okay, IP address. Here using port number in the port in layer 4. Okay, port number. Here using MAC address in the layer 2, data link layers. So the flow coming from up to down, when this information received, the upper layers as data to the port layer as a segment, will make encapsulation. Then Other encapsulation for network header will take all the information inside here as information data and make network header and with IP address for source and destination. And same will be for MAC address. We'll receive all this information as information here and make a layer 2 header for MAC addresses, source and destination, and will be bits. When the information received to other side, the flow will be from down to up. When this information received, let's consider this OSI, okay? Consider OSI, same layers. When received to up, this physical layer will handle the bits to the data layer will be gathered here as a frame. After that, will de-encapsulate the header of the layer 2 link, data link, and to know the MAC address for the destination. It will handle this information to network to encapsulate the information and get the IP address to which device in the networks, and this transport will take all the information and encapsulate all the information of the port numbers and handle to the PC application which has the same port numbers. The communication between two devices like this in certain networks. So I think it's enough communication and explanation about OSI and internet or TCP/IP model. Okay, so let's move to. I mentioned the encapsulation already. Okay, then I also mentioned this one, source destination for frame MAC addresses and the IP addresses for the network layer 3. Okay, I already mentioned this one. This is the application protocols, transport UDP or TCP, and so far I already discussed about it. So about IP addressing. IP addressing, we have main 3 IP addresses. We have 32 what? We have 32 bit for IP version 4 IP addresses. 32 bit is divided to octet. We have 4 octets. Each octet 8 bits. 8 bits, okay, total. So if you are talking about class A, okay, class A started when? From 1, the first number of the IP from 1 to 126. If I found IP address, let's say 10.10, okay, the first number is 10, that means belong to class A. Class A is designed for enterprise large companies like Microsoft, like maybe very large IBM. They have millions of users. Why? Because the first octet is designed for network, and the 3 octet here designed for what? For users. Each users has IP address. Okay, for example, I have 10.10, make it easy, .10, no problem, make it an easy, okay? I have 255 here, I have 0 here, 0, 0. This is called a network mask, or subnet mask. It's called a subnet mask. When I have 255, that means only one. For first octet, that means it's class A. Class A, I have only one, for example, okay? 1 octet for networking, that means 255. All 255, that means for this first one octet, this is mean class A, 000, those will be class A. That means those has the users. How many bits? I have, calculation will be 2, I have 8, 8, 8, 24 bits. 24 bit, how many users I have? We have maybe 60 million users, something like this, or something like this, or more maybe. I forget. Because some company have 1 million users, for example. they can reserve this for their own company. ISPs will be using also class A or class B, whatever. So let's talk about class B. Class B, it starts with 128. You said 127. What's 127? 127 is you reserve for local host in any computer. For example, I go to here. Let's say my local host exists or quit. Bing local host is bingable, should be. You see? What also I can say Bing my local host 127.0.0.1 is reserved for any computer, any device. Same. This is the IP address of the local host. This is the local host. I can put the name or the IP address. Now, 128. Okay, tell what? Tell 191 is class B. Class B. It has two octet 255, 255, 255, 255 for the subnet mask. Another two octet for users. That means users have 2, 8, and 16 bit. I mean the power of 2, 16 equal maybe 65,000 users for each IP. Sorry, for subnet mask. Maybe I have, let's say, 128 dot 20.5.5. This is fixed for networking. I can't change, but only I can change this one. I can put a number from 1 to 254. Let's say here 1. I have for 1 I have 254 IP address. 2 to 454 address. Okay, that means I have total around 65,000 users. Okay, for class B. For class C, for 192, and I forget what the number, maybe 223 or 224. It has start from this one. Okay, it has 192, for example, 168. This is a look like most of the user the companies for class C use this one, 192, 168. Maybe you can make 2020, no problem. But it's because it's internal network, not outside, not public. If public cannot use 2020, by the way. Okay, cannot use it. Should be follow the standards. 192.168.5. This is fixed for class C. You need only to stay in the last octet from 1 to 254 and 1. Maybe 5.1, 5.2, and so far to 254. This is the class C, and you need to put the net mask. What? 255, 255, 255. That means the first 3 octets are fixed. This one I cannot change. Only dot 0, 0 where I change the IP address. The last octet here I can change from 1 to 254. I hope you understand this IP address and routing, okay? And this is here the class B, okay? The same explanation. Network ID, 2 octet for host, I mean users, and the class C 3 octet for networks ID, and the last for users host is 12254. Okay, the range. Only this I can change. Class C. Okay, D is for multi-class. I think 2 start 2 to 4. I think. Class E for some is reserved for maybe R&D. Okay, research and developed for some specialized area. I forget them start from where. Okay, yeah, nobody uses those things. Only A, B, C. By the way, IP version for this IP addresses it is limited. Okay, is limited. That's why we have IB version 6, where support billions of users. Why? Because IB version 4 maybe support maximum. If you take, for example, here 60 million only for one company. If you have many companies, different options, will reach to maybe 2 or 3 billion or some billion of IP addresses for version 4. Okay, imagine nowadays we have IoT devices. I already have video training in IoT. Go to IoT in the list of my channel and check the IoT. I discuss about IoT, how to configure IoT, what's the IoT, Internet of Things. Nowadays we have more than 30 billion devices, so it cannot work with version 4. I have version, it can work with version 4 for no problem inside the networks, but I mean total routable and public IP address should be version 6. If I need to use specific IP for each IoT and should be unique IP all over the world, I need to go to version 6. It supports I think 2 power 128 bit, because it have 128 bit for version 6, IP version 6. Okay, it has what? It has 122 bit into 8 groups. Okay, those groups are hexadecimal groups. 1, 2, 3, 4, 5, 6, 7, 8. Each one is 16 bit. Okay, 16 bit. Total 128 bit. That means I have 2 power 128 bit is the total of the user I can use in IP version 6. It has very large. I cannot give you the number. I don't know the beyond of billions something, and beyond that something is something else. So it look like unlimited user. If you'd like, I can explain now. So here I found for you article about version 6. It has 340 decillion of the IP address number. Look like 2 power 128. We'll give same number of this one. Okay. So what else we have? Okay. We have, as I mentioned, 8 group. Each group is hexadecimal, have 4-digit hexadecimal. Okay, and the separation with colon separation. Okay, colon separation between each group. As we see here, the first 2 group is for in some kind of let's come here, some kind of type of IP address, global unicast. Okay, global unicast, it up to 32 bit. Of 32 bit is reserved for what? For networks, global network. I mean outside public networks. First 32 bits from 128. I mean the first 2 group, which is here 16 bit and 16 bit. This is reserved for global unicast address, which is routable what? Publicly in the internet. And we have link local address. This is if inside your networks. Okay, a single networks, local networks, give you local, will be started from what? After 32 will be started from, it will take 16 to 48 bit after 32, first 32. Okay, if for example, if global, but if link local address, okay, will take what? First one FE 80 and whatever you put the the address. For example, if you have two double colon, that means the IP address like this: FE 80 0. I have how many octet group? I have many groups, right? Here 0 0 0 0 0 0 0 0 0 0 0 0. Okay, the shortcut of this one, what's the shortcut? Shortcut like this: only double colon. Double colon mean all are zeros, only the last what? Link. Okay, maybe the last one I have to 7F0E. That means all the groups are 0 0 reach to that last one, and the first one is like this. Okay, when you found FE80, this is local inside the networks. When you go outside, there's some range for global, and the first 32-bit is reserved for global. Okay, then we have unique local address with the site organization also, start like FC00, similar to that other one. So the beauty of the version 6 has anycast and multicast, but it has no what? It has no broadcast. Also, it has no, here's the summary. Here's the summary, okay? And also there's no nothing in IB version 6, not only for IB version 4, because in NAT I can map a local IP addresses, maybe have 100 to one public IP to go to internet, because I have a lack of IP addresses. Okay, that means in this way I can overcome some difficulties of version 4 IP addresses, where I can use locally in my enterprise network, or our local IP addresses. Okay, private IP addresses look like class, even class A, class B, class C, I can use in my private, whatever. But in the router or firewall, I should use public IP address. Okay, and I can let all those IP addresses map to public IP address to go publicly using nothing. Okay, network address translation. We'll discuss about it later on. I think still now I think it's okay for this one. I give you good information about what about IP version 6. So whatever I need, I go to TCP protocol. As I said, it's oriented protocol because it has handshake to communicate. Make synchronization to the, let's say I have two devices, client and server. First, client communicate with server, make synchronization, and server okay will reply with acknowledge of synchronization. After that, the client can give the full acknowledge with data, transfer the data. After that, the server transfers the data until sometimes there's some FIN message coming from the client and the server to just verify the connection is on time. Okay, is uplink. After that, keep sending data, and the end we have reset of the TCP to close the session. Okay, the packet size 64 kilobit per second. Okay, for the datagram, the upper layers, when it can be fragmented to 64 and sent as a packet. Okay, so what else? The protocols for layer 7, many protocols I mentioned already. NAT, I mentioned already NAT for you previously, but again here, NAT has some 3 different type of NATing: static, dynamic, and PAT. Okay, let's talk about PAT, which is most cases of our companies doing this. So I have, let's say, 200 users, 200 IP addresses. Okay, but I have only one public IP address in my firewall, one public. Okay, one public. Okay, I have one public IP address only. I cannot buy many public IP because it's very expensive from the ISP. So what I will do, any user, any device, whatever, he need to communicate to, let's say, go Google, okay? Google is easy, Google server, let's say. He will send the packet, maybe he open some application, X application. X application has different port number, okay? Then his source port number, this one, and the IP address, source his IP address, okay, for Alice or device. Then his destination IP address will be Google. What happened here in the router or the firewall? He will receive the packet and he will remove the source IP address of the user and he put his own user, the firewall, the firewall IP address, not the user IP address, and he keeps the port number. Maybe he can change the port number to destination port number, for example. Instead of this, he can change to destination different port numbers, and he send to Google. Google will reply with the same port number as in Google will be the source port number is his application Google, and the destination port number will be the same port number received from the firewall 777, okay? And he will put the firewall IP address as the destination IP address, not the user, the firewall, because he don't know the user. Uses firewall and route is a proxy, okay? He don't know inside. Then the firewall will receive this and he replace the firewall IP address to the local user address because he knows about the port number and he knows about the MAC address inside the table of MAC addresses inside the router, switches, and firewalls. As I mentioned in previous slide about MAC addresses, source and destination. Like this, communication will be done for the companies using PAT, which is what? Port address translation. It is dynamic netting, okay, but using only one public IP address. One public IP address only using. For the dynamic, similar to PAT, but in the public address, they use a pool of public IP address. Pool. Maybe have 20 public IP address. Let's say they put some, maybe each time the session will come and he use different public address and set, because maybe they have 100,000 of users. They cannot use one public IP address. They should have used many public IP address. In some cases, we use static IP address because if using PAT or using dynamic, I need to map I have, for example, here one server. It has application, okay? It has IP address .100, for example, okay? 192.168.1.200, for example, okay? Now, I need to, this user outside in the internet, I need to access to this application. But I cannot access to his private IP. And to access to the public IP, whatever the public IP will be, will map this public IP with this, what? Private IP with different port number for application using inside that server. When I need to communicate with the server, I use the public IP with the port number of that. And the firewall, he knows this is mapped to private server IP address and will make connection from outside to inside. I hope, let me go down, maybe have more. Yeah, I think here. Okay, I discussed about LAN, right? What one? One wide Ethernet network, it has a lot of LANs inside each area in the globally. In the globe, there's many LANs, all together called one wide Ethernet networks. Maybe Google have LAN, have a lot of servers, a lot of PCs, a lot Amazon, Google, any company, it has their own LAN. LAN could be cloud, data center, whatever could be. Okay, could be small LAN, whatever. All of this consists the WAN or internet. Okay, internet has also inside ISP and the connection between LAN to another LAN or internet using ISP, local ISP, then international ISP, and so far to connect to the destination LAN, for example. Okay, MAN inside the city, it's called MAN metropolitan area. It's just a city. So most important, LAN and WAN, to give you the holistic story and overview of the internet. Routing protocol, when send packet from this device in this LAN, okay, to other LAN device, we'll go to the router, firewall and routers will make, the routing protocol will make the destination the best route to destination. Maybe it has, for example, this is the company, okay, connect to the router. Inside the ISP and the internet or the WAN have thousands of routers and connected as a mesh, as you see here. Well, routing will find the shortest and best way to reach to the destination, okay? Maybe this way is have traffic, heavy traffic, go to other way. Not only shortest, less traffic as well, okay? To reach to the destinations. DNS, domain name server, to reserve the fully qualified domain name. For example, as we are human, we know only names, google.com. We don't know the IP address. Who do translation between the name of as human, readable name of human, to IP address as language in the PC or the network device? The DNS map the IP address, because any device has IP address, even Google server, whatever have an IP address. So who do the map between the name of the Google domain name to the IP address of the Google? Is DNS. When the person from here in request go to Google, for example, well, there's DNS request will become, and the first DNS server inside the networks should resolve the IP address of the Google, because there's a cache, okay? First time, no cache. We'll go, let's go next slide, I think it's better. Before this used to be here, I think, okay? If I make, for example, in slookup, okay, maybe -4 or slookup, okay, -4, that means version 4. I can put here set type any equal any. Now I need to reach to google.com, for example. So Google, the first DNS server, this is the name of the server. It will resolve for me the Google to IP address. Okay, sorry, this IP6. Okay, let's now make quit and make quit. Sorry, and make DNS lookup -4 version 4 IP version 4. Set type any request google.com. I need to, so this is the IP address as IP version 4 of Google. Okay, it resolved for me the DNS non-authoritative server. It's also kind of DNS. Okay, the nearest DNS. It can resolve for me. If not be able to resolve, we'll go to what? To different DNS. First, this is my computer. Request Google or whatever, any domain names, and if my local DNS can resolve, okay, not can resolve, we'll ask the root servers and top level domain. If this is top level domain responsible for some kind of domain, .com, .net, .org, and so far, and at the same time we'll ask the authoritative domain servers. Okay, all of them will return back and give you the full domain name mapped with IP addresses to that device. And I'm using NS lookup for that reason, how to resolve the IP address of the Facebook. As I mentioned, Bing -4, that means IP version 4. I put the Facebook the DNS server, name server, then I can reach the IP address of version 4. If I not put -4, it would take automatically -6, which is version 6, and give you the IP version 6 of that Facebook name server, and so far. So DNS root name server, that one. Contact by local name server, this local name server. It cannot resolve the name. Then the root server, that one, can contact the authoritative name server, this one. Okay, if the name mapping not known, then get map and return map to local name server. Okay, and so far. TDL store the information like .com, .net, .org, whatever extension of the name servers, and store the information for this website with those type of domains. Okay, authoritative name server is the last server in the domain name, stores the IP addresses mapped with the website. Okay, and local name server does not strictly belong to the hierarchy. Each ISP has residential IPS company name server. Okay, first name server in my company, go to the DNS name server to resolve the IP address from the domain name. If not, we'll go to the root server, top server in the meantime, and then we'll communicate with our authoritative server to return back the IP address of that domain to communicate with that device or server in the Google, for example, or Facebook. DSCP, the last for networking, DSCP. Okay, we have two kinds of DSCP messaging. First, in the network, our computer, let's say my computer, it has no IP address. Will receive IP address for DSCP server. Any computer, there's a broadcasting or multicasting called DSCP discover. Will discover any DSCP server in the network will send request, and in the meantime, the DSCP server will send DSCP offer. Is offering he can give IP addresses to computer the request for DSCP. First, DSCP client server interaction. How it works? The client broadcasts DSCP discover message on the local networks, and the DSCP discover message maybe includes some option like network address suggestion. I need IP address of network. I need the default gateway. I need the DNS. Okay, and in the meantime, the server will respond to that DSCP offer, discover by DSCP offer, give the IP address, the network gateway, okay, default gateway, and DNS and IP address to the devices. It works like this. I think up to here is enough. DSCP, HTTPS, and SSL, TLS. I discussed about it in different session for web session for security, web security. And thank you. This is very long, for example, networking session because it covers a lot of information good for you, for your academic or for your workforce to understand all the things, and it has good information. Thank you for watching me, and in the next session I hope to go to the lab of the cybersecurity where we have CHH. First we do board scanning and reconnaissance and discuss about Google hacks, how to gather information as well. Before that, I need to install the lab. I'll show you how to install the lab. It's easy, very easy. Don't panic, okay? Then I will show you step by step how to do the first stage of cybersecurity. Thank you, and don't forget to make subscription, sharing the information, and please, if you have any comment, share it for all of us to get useful. Thank you, and see you for the next session.